First of all, I really would like to thank the SONiC chassis contributors. We have companies Arista, Nokia, Cisco, Keysight, as well as Microsoft, who have been working hard in the past 1 to 2 years to contribute to chassis enhancements, development, testing, etc. So really like to thank them. And also all the discussions in the chassis subgroup as well. For those who are new to this, I'll just have a very quick introduction of the thought process of this. So in the past, SONiC was only supported in a fixed switch pizza box, typically with one ASIC. And then there is some other platform which has actually multiple ASICs. For example, there is a platform that is basically have 6 ASICs connected in a cross fashion. So we started the SONiC multi-ASIC design to support this platform. And it's actually completed and in production already. So then we look at the modular chassis, and we could see that they are actually very similar. The ASIC are also connected in a cross fashion. And with this, we will apply the same design for SONiC modular chassis design. So now let's put the things together, right? So for each of the front-end ASIC, meaning the ASIC that is serving the front panel ports, we actually have BGP instance running for each of these ASIC. And then the BGPs will form the fully meshed iBGP sessions among each other. SONiC currently supports 2 main types of chassis architecture. One we call VOQ or cell-based, and another, it's, we could say it's a packet mode chassis. And what's the difference between the two? So for the VOQ or cell-based, probably people are quite familiar with it. The packet is disassembled into cells and then forwarded across the fabric ASICs inside the chassis or the fabric ASICs, and then it would be assembled at the egress ASIC. For the other one, each ASIC is actually doing independent routing and forwarding. But they actually are still quite similar, meaning at the fabric ASIC, at the back end, it's kind of a cross connects. So then at the fabric ASIC, for the packet mode, we could actually use regular layer 2 switching to simply switch from one port to another. Now, what are the new things that we would need for SONiC modular chassis? So basically, in the supervisor, we call it supervisor SONiC. There are 3 major functions, right? Number one, the fabric, there are multiple fabric ASICs, and which is programmed from the supervisor card. And with such, we also apply the similar SONiC multi-ASIC design. For each of the fabric ASIC, there is one SOSS Docker container instance running. And number 2, the supervisor needs to gather or help to exchange certain information for the line cards. So then with this, then we added a new chassis Redis database. Number 3 is what about the platform management? So there is a chassis platform manager to be responsible for this. For example, the thermal-related monitoring. Now, what about the chassis platform manager? So for chassis platform manager, it's actually still achieved by the PMON Docker container in SONiC. There is a single PMON instance in supervisor card, as well as at each line card. So the line card would actually publish the voltage and temperature-related information in the chassis database in the supervisor card. And then the chassis, the supervisor SONiC would run a centralized algorithm based on those published sensor information. The chassis platform manager may also do monitor the power supply units and then maybe do some line card operations as well. And then on the line card, because the LEDs and transceivers are present on the line card, so those could be directly managed by the PMON on the line card. So that can include the SFP monitoring. Now next, we can take a look at briefly on the fabric links, especially in the VOQ system. Fabric link is a type of side port. It inherits the existing side port statistics and also the new side port statistics added. For example, CRC errors, fact correctable or fact uncorrectable errors. With this, then the community also added fabric link monitoring feature to monitor the CRC errors and uncorrectable errors. And then we could also see the fabric link status, receive, transmit cells, etc. So monitoring the internal link health is very important. Regarding the communication between line card and supervisor cards, at a high level, this is mainly done via the Redis TCP communications between line cards and the chassis database. At the lower layer, this is actually implemented using a midplane, which could be a hardware switch or it could be a software switch. Both supervisor and the line card will have two IF interface. One is the IF0, which is the management IP, and then the IF1 is for the midplane interface. If the line card has multiple ASICs, then there will be multiple Linux network namespaces. And so with that, we have a layer 2 bridge, Linux bridge, so that the Dockers for the namespace could be connected to the midplane as well. So basically, this would support the management infrastructure for the chassis. So then, how do we manage the SONiC disaggregated chassis? So here I show an oversimplified view of a management controller. The supervisor card and the line card each can be modeled as a separate SONiC device. So we still have the same set of management daemons running on each of the modules. So the management controller would still have the standard services, for example, image upgrade service, config services, or telemetry clients, etc. And then these services could manage each of these modules either independently or in parallel or collectively. That depends on the applications. For example, you could collect the syslog information on every single module, and then or stream the information from every single module in parallel. But then you could actually generate alert only for a given module if that module has issue. And then regarding the image upgrade, typically we would like the supervisor card and all the line card to run the same image version. But actually, this architecture doesn't preclude you to have a different image version on some of the line cards. So that depends on your needs and, of course, whether you really support that or not, right? Because if you are multiple versions, then the testing and so forth and management will be another work. And for configuration, currently we use minigraph. We have a minigraph file for the sub, as well as a minigraph file for each of the line card. So SONiC would pass this minigraph file and then self-generate the configuration and store the data in the config databases in the module. We have one config DB for each of the ASIC. And then in the future, we could generate the configuration based on the Yang tables. Finally, some chassis abstractions could be needed depending on the applications. So now I will turn over to Arvind to talk even more about minigraph and some more interesting areas.
Yeah, so today, as Rita mentioned, we use minigraph to configure the SONiC chassis. So since we model each device independently, we'll have different set of configuration going on every line card or supervisor. So we have a separate minigraph file for every line card and one for the supervisor. So each line card configuration is independent. It will have all the ports, IP, VGP configuration to talk to external or internal peers, other management plane related configuration for SSH, monitoring configuration for syslog, TACACS, and so on. Depending on the architecture of the chassis, there are some metadata needed to initialize the SI. So that also gets passed in the minigraph. And there are also certain data which is needed for initializing of each ASIC. For example, in VOQ architecture, we need to know the system ports and so on. So those information also gets populated in the minigraph. For the Ethernet fabric chassis, since the fabric itself has configuration, so there will be port channels and IP interfaces, and all that information is carried in the line card minigraph. On the supervisor, it's again, we'll have a subset of the configuration, like management planes and configuration needed to initialize the fabric ASIC, and syslog, NTP, and other utility configurations which are required. So as we model each device independently, so we could log into every line card individually, assign them like unique management addresses, do management operations just like we would do on a SONiC pizza box. Apart from that, each line card can be accessed via the internal midplane network as well. So leveraging this, we will be developing new CLI utilities where we could execute remote commands on each line card or on all the line cards from the supervisor itself. So this will be helpful for automation frameworks to get information at a chassis level than the line card level. So these are some of the new things we could do by leveraging the internal midplane network. So for testing, the main idea for testing the SONiC chassis was we wanted to leverage the SONiC management test. Most of you might be knowing SONiC management has more than like 1,500 tests, but all these tests were defined for a SONiC pizza box. So to leverage that, we had to improve the SONiC management test infrastructure. So the basic idea which we thought was to design a chassis as a collection of DUTs. Each line card is a DUT and a supervisor is a DUT as well. So on the right, I have a sample diagram of topology with four devices, 3 line cards and a supervisor. And then we could run tests basically on a single ASIC in a line card or on all line cards or on a given line card and so on. To better abstract all these complexities from a test case designer, new classes were defined so that new test case could be added independent of whether it was done for a pizza box or for the chassis. Okay, so I have a small demo of interop between chassis from Nokia, Arista, and Cisco respectively. So I'm going to play that video. How do I play?
Hello everyone. Today I'll give a short demo of the working of SONiC chassis on different hardware SKUs from Arista, Cisco, and Nokia respectively. So in this demo chassis, we have 4 SONiC demo topology. We have 4 SONiC chassis connected on a combination of 100 and 400 gig links. Each of these links are MACsec enabled links. And we have MACsec running between these 2 chassis. All these SONiC chassis are connected via BGP sessions to advertise and receive routes among these chassis.
Sorry, it's not moving. Let's see if we could play the actual big audio.
Hello, everyone.
But it's not showing here. Oh. Eh? It's not the, still not the same, right? Yeah. Why it always? Yeah, let me see. Yeah, it always switch to extend display.
Hello everyone. Today I'll give a short demo of the working of SONiC chassis on different hardware SKUs from Arista, Cisco and Nokia respectively. So in this demo chassis, we have four SONiC demo topology. We have four SONiC chassis. They're connected on a combination of 100 and 400 gig links. Each of these links are MACsec enabled links, and we have MACsec running between these two chassis. All these SONiC chassis are connected via BGP sessions to advertise and receive routes among these chassis. For the purposes of demo, we have two VMs connected to Arista and Cisco chassis respectively. And in this demo, we'll try to ping between the loopback addresses of the stuff. So we'll ping from 200.1 to 100.9. So another thing we will showcase in the demo is the internal route propagation within a chassis among the line cards. For this, we have the VM connected on this Arista chassis on a different line card, and we will see that the route learned from this, the loopback address of this VM is propagated through the internal IBGP session within this SONiC chassis. Jump to the demo. As I said, there is MACsec enabled between all these links. So we can see that, for example, on this A60, we have MACsec sessions established between Cisco and Nokia, and we have the same thing across all the four chassis. So if we dump the BGP summary, we can see that this Cisco chassis is connected to Arista and Nokia, and this Arista chassis is connected to Cisco and Nokia, and the same across all these four devices. As I said, the VM on the Arista chassis is connected on a different line card. So if we dump the route for this VM's loopback, we can see that the route is actually learned on the uplink line card via the in-band addresses, in-band interface connected to the downlink line card. So if we jump to the VM and if we try to ping the loopback addresses across these VMs, we can see that the VMs are able to ping each other. Thank you. Hello everyone. Today
Yeah, I'm finally called for action. So we have a bi-weekly SONiC subgroup meeting. Everyone is welcome to join to discuss more features which need to be added to SONiC disaggregated chassis, review PRs for code or test. The links for the wiki is mailing list and the GitHub repos present in the presentation. That's all we had. Thank you.
Just, one question. So would it be correct to say that the current implementation supports BGP-based data centers, but not like, I don't know, an OSPF-based data center? Would it be correct to say that the current implementation would say support a BGP-based data center, but not say an OSPF-based data center?
That would be correct, yes. So it's
Does
today
it
we
or no?
use BGP.
Oh, so it would support a BGP because you're moving state between ASICs using BGP, right? And
Yes. So we have, as Rita
peering
said,
is distributed, right? So
so between ASICs, there is an IBGP sessions,
Yeah.
which is used to propagate routes across the ASIC.
okay, so it doesn't support like an OSPF-based data center.
No.
Okay, I just wanted to know from a protocol perspective, like looking beyond the box, what does a network have to look like in order to use it? But it's good. If you're BGP, you're good.
Thank you.